All right, so it's my great pleasure to have you here. Hi, Takashi.
Hi, Olaf.
So we are having this nice conversation because you received a very nice Lifetime Achievement Award this year. So that's to recognize individuals in artificial life who made very profound contributions to the field. Influencing through their work and through their mentoring many people, and it's definitely your case. So today I'd like to just have a casual chat with you and talk.
I think you also should introduce yourself. Why?
Okay, yeah. So my name, for those who don't know me, is Olaf Witkowski at Cross Labs, and this is Takashi Ikegami at the University of Tokyo. All right. So
and you joined our team like 10 years ago, right? It's already 12 years ago, right?
Yeah, it was something like 10 years ago or more. Yeah, that was an exciting time. So I think the first time I joined your lab, like I gave some talks, and one of those talks we had a huge fight.
Yes, that's right. You came up with this binary model for cultural evolution, right?
You didn't like those models. But I still like them. I think those.
I know. You like a binary string models. Yes.
Those models were nice. So maybe to get to know you a bit better, maybe first question would be, what is ALife for you?
Yeah, that's very fundamental and basic questions, right? Actually, when I came to know artificial life was when I was a grad student and I came to visit CUNY at Los Alamos. Then I met so many interesting people at Los Alamos, like Norman Packard or Jim Crutchfield was there too, and Duane Farmer was there too. Right? Those people studying chaos. Right? So there's a Center for Nonlinear Sciences, and then the people start doing some crazy computer simulations on interest stuff. Right? And Sten Rasmussen was also has joined the group since 1988 or something. Right? Then I came to know that the people also wanted to understand what is life, not by looking into the real living systems, but doing computer simulations. So it's a nice level of abstractions over living phenomena, systems phenomena, which I really like. Right? Yeah. And also Norman Packard, I don't remember when was it, but he came to Komoba, the University of Tokyo. And he gave a talk on the immune system, immune network. Yeah. And that was very much impressive because people who have been doing physics came to Komoba on a big seminar, and he was talking about the immune network. Yeah. And nobody has ever heard of this. Right? Why this guy is studying immune systems? I was very much impressed with this talk, and I started to understand what's this chemical network, right? If the neural network is for separating mind from others' mind, then immune network is separating material self from external world. So it's a separation, or like the autopoietic theory for the material system. It's the chemical. It's the immune network. Which
how did that connect with your previous interest, and how did that make you somehow transition? What was exciting in there that drew you in?
The people also, if you have to study mind, or if you want to understand what is life, you do some. It's more like a philosophical questions that people cannot answer these questions from just merely studying physics. But Norman Packard or other nonlinear systems, people studying nonlinear sciences, can attack those problems by computer simulations. So you don't have to do philosophy, but you can just do computer experiment. Then you can tackle this problem, which I thought was very nice, right? And that there was Bob Rosen, and then Michael Conrad, of course Francisco Barrera, and other people. Start to discuss all these kind of interesting concepts around what is life, what is how to understand
and somehow
systems.
Making contact yourself with this interesting group of people, and I guess which year was that to situate? Was that 1980
something.
Right?
Yeah.
And so you came into contact with those people, and you started discussing those concepts.
Well, yeah. Well, actually, I didn't have the strategy, or I wasn't prepared. I wasn't old enough to discuss these complex phenomena. So I have to do my own computer simulations to understand what's going on there, right? What you can do with the computer simulations. So when I visited Los Alamos, I noticed that the mainframe was stacked because of computer virus. And everybody came to the computer room and discussing, what's going on, right? I mean, you can't receive any mails. That was the first phenomena that actually this computer virus is stuck in the mirroring system, and then it crashes, right? So the boundary between what happened in the computer, what happened in the real world, it becomes seamless. So that's my big
interesting. So you found some traces inside those simulations, inside those inorganic kind of forms or patterns that you found interesting to analyze, and maybe through those conversations you dived in. And what was your approach then? Like, was it something different in the beginning of your research in artificial life?
Well, for the artificial life, I studied from the computer experiment, right? Because when I came to the graduate course, as a normal physics student, right, we studied did some analytical calculations of like spin glass systems. So that was something that I was doing. But then I was more interested in neural networks, because there was a Hopfield model that the physicists got interested in, how to understand how the mind works by studying modified spin systems like Ising models, right? So they try to find like a minimal toy model that can explain how the mind works, how the brain works. So I got interested in this one. So studying maybe the network model can explain how the mind works, or how how the self emerges from something, right?
So somehow in all those systems, it's something rather simple that you can have in a box of computation, right? That you can observe and you can fully simulate, and yet it seems to be bearing very high concepts and maybe meaning and those things that you attribute normally just to life, and maybe something like that was really exciting to you then.
Yeah, well, I wasn't quite. I don't remember what I was thinking at that time. But for example, like memory is something. It's different from what we say memory in a computer. The memory in the brain is pretty much different from what we can do with the computer. So that's something that was a simple target that I want to understand. So it's not, I wasn't targeting what is life or life itself from the beginning, but I was just interested in how to understand hierarchical memory structures, all this kind of stuff.
So that was definitely exciting times for artificial life. It was just starting. It was a fully fledged field like it is now.
That's right.
And what were impacts that you experienced within your research, and maybe you saw around you in the evolution of the field? What were the main, I guess, what is it?
The good question.
Points that were exciting.
Well, like I came to talk a lot with Tom Ray. Tom Ray was one of the pioneers of artificial life, and he did this autonomous, self-replicating program.
Yeah.
The program itself is, evolving by itself by interacting with other programs within the TIA platform. Yeah. That was one of the things that I encountered with artificial life programming.
Yeah.
However, I was more interested in nonlinear sciences, not Taylor-like programming. Right? I thought programming is okay, but I think that's not the abstraction level that I was interested in. I was looking for. I was more interested in more pure dynamical systems. But the dynamical systems, we have to specify what is state, what is function, right? And once you specify this is a state for this dynamical systems, then everything is it can run without me, right? So that's the dynamical systems. However, the living system is something different. We have to rethink what is state or what is function and how the function is defined by other functions or something like this. This should be entailed by the other systems within the system. This kind of self-looping kind of difficult question is something that people I think tackling for, right? For example, like Francisco Barrera or the books that I have right now, like Endophysics or the Life Itself by Bob Rosen. Those books are all about how you can entail something that yourself within the system or something. So the dynamical system is something different from that, right? But I was trying to understand this complex self-looping idea from the dynamical systems, which was I think it was very difficult, and it was not so much matured problem. We have to think about the meta-dynamical system which can generate dynamical systems from that system. This kind of system this kind of idea must be more brought about.
Yeah, I think, and then we should also mention I forced you to bring a few books with you today.
Yes.
But maybe before that, there's definitely a few threads in artificial life, right? So you mentioned these viruses like world, like and models like Tierra, etc. Avida. Those are models that study basically evolution and its emergence inside a system and how that changes and the dynamics of that. And you oppose that to the study of dynamical systems, which is also a huge other thread. I guess I think you have this nice map, right, like of how you see artificial life. I find it very interesting. So it's a bit messy, like it's a sort of tree with parallel threads running. Can you say a bit more about that?
Well, actually, I thought I was somehow against conventional theoretical biology approach because the people try to explain living phenomena which already exist or should exist like a billion years ago, right? But what I'm interested in is like the life in the future, right? What life can evolving into what, or how can I understand, life-like phenomena, not life itself. I mean, not the biological life that you see. So it's not. So I'm not just interested in explaining something that you see, you think is interesting, but something that you generate, right? So generative approach to living system is something I'm interested in. That's what I call artificial life. So artificial life is all about generative science, new kind of science.
And that somehow you generate from scratch.
Generate from scratch, and generative is even if you prepare these functions on this state, but you cannot expect what is coming out, right? That's what the generative.
I remember working in your lab for a while. You pushed us to first every week have a plot that was exciting to us.
Yes, that's right.
That was a very nice exercise, but also I think that's very much your style as a researcher. Tell me if I'm wrong. But to look for surprises. So not planning the result. It's very nice also to plan the result from the end, right? Like the end point. This is where I want to get to. But in your case, I think you want to genuinely be surprised by your own results.
Yeah, that's right. I mean, usually that people say there's a exploration and exploitation especially in reinforcement learning or something, right? And AI, I think AI is artificial intelligence is for exploitation, right? But the artificial life is about exploration, right? Exploring what's out there in your computer simulations or simple experiments, and that's I think is very much the spirit of artificial life. That's what I'm interested in.
So is that the secret recipe of ALifers right now? Is it what makes so what characterizes the field, do you think, in the time? So something like Inman Harvey says, we are the scruffy bunch.
Yes.
We need to be scruffy, and it needs to be somehow disorganized. If we organize ourselves, the field dies, right? Is that your point of view?
Yeah, I totally agree with the Iman. Yeah, that's our style. And then also, you always have to, do experiment. I think it's, for me, the science is about experiment, and then artificial life is basically it's the experiment. It's not the organized planned experiment, but it's you start from some scratch and doing this and this, and then accidentally you can find something interesting, and then that you start from there because it's interesting. It's very much attractive phenomena, so that you can build up something interesting, right? Yeah. Maybe something that you can make is mapping onto the living systems, but maybe not. But first of all, you have to have some interesting phenomena first, and then the explanation about biology is secondary to me.
Yeah. And somehow, I guess some of this can map onto, like you say, onto living systems as we know them, and something may map onto new forms of life. You talk about future life, which is very exciting, right? So it's true, life is changing, and we somehow are going through transitions, like we saw in the past, through the major transitions in evolutionary, in the evolutionary path of life. But in the future and right now, we are transforming through our interaction with technology, perhaps. There is a transition going on right now. So is that what artificial life is studying in your?
I think artificial life can commit something to the future life, right? And then I think that's one of the value of artificial life. But the artificial life itself is more about not about things, right? I mean, but it's more like it's about mathematics. To me, it's the branch of mathematics is artificial life, but the definition of mathematics is not just numerals and functions or things, but it's more like a generalized mathematics.
Yeah, so it's somehow mathematics of life as it could be something like that. Yeah. Your nickname on Twitter is
artificial life larger than biological life.
Larger than biological life. Yeah. So is that your motto? Is that
yes.
So you had it for a while. So has it changed? Or that's still your view?
Yes, still my view.
Yes. Still your view.
Usually the people want to apply. So here's the nice mathematics that they want to using this mathematics to describe what's the life phenomenon that you're interested in, right? Yeah. But what I want to do is looking at this life phenomena or crazy ideas about the living systems, then what kind of mathematics that we can create from it. That's I think this is one form of our artificial life. So artificial life should be the seed for creating a new language, new mathematics. Yeah. So it's not the other way around. Here's mathematics to apply to understand the existing life, but we have the idea of living systems. We already abstracted some aspects about living systems, so that we can make mathematics from it. So that's what I think is.
It's very exciting, right? It's and we are living it right now. So we are, and it's hard to detect because we are living it, and yet I think you are you spotted that in some talks. You talked about this tipping point around 2010 or so. Can you say a bit about that?
Yeah. Thank you. That's actually that's why I switched from the computer simulations to the real world experiments and things, because before 2010 I think people were studying what we call storytelling or narrative approach to living system biological systems, because we don't get so many data, we don't get so many the real experiments, but we have nice dynamical systems and do some experiment, so we can make some nice stories about what is evolution or what is life, right? Yeah. So the story was more actual than the real, right? But after 2010, I think it has been different. The data becomes so massive and so in detail, and that overperforms overcompetes the storytelling or narratives. So the story never becomes actual to us. The data, the complexity of data flow becomes more actual to us. So that people cannot be convinced by telling the story of the phenomena, but we need what is fact or what is data, and then the complexity in the data becomes more actual. Right. That's what happens after 2010.
Right. So I guess and data keeps growing, right? So a lot of data is created by complex systems and by living and other systems as we go, and becomes harder and harder to have a sort of understanding of what is happening and spotting the real significant dynamics. And so how? What are examples of this? Maybe to understand.
Well, I noticed this one because I was reading a newspapers about the Rubik cube.
Yeah.
The Rubik cube was solved by Rokiki with a team of Google Inc. That the 20 moves is the minimal numbers of the move that you can solve the Rubik cube.
Yeah.
This was reported in 2009, and then he used massive Google computers. But actually, what he did was he made a big table. So looking at this big table that you can find how to get to the solution, right? And then he counted that there was the 20 is a minimum number. That's how it started, like a 4-color problem, right? You don't have simple solutions or simple answer to the questions, but you can have this big table, but still you can solve the problem. And then that's one way to understand what the Rubik cube is about, right? So if the answer to what is life is like Rubik cube, then the answer can be like this. Well, of course, the people cannot be satisfied with this, but if that's the way that we understand the life, that it is. So I was interested in what is how this if the world is looks like this, then we have to change the way that we understand the world. So usually the people keep this is the way that we understand the world, right? But what we have to do, we have to change the way that we understand the world. So that happens after 2010. And also there's the movie from Max Planck Institute, the zebrafish, starting from the 64 cells, and they have completely, recorded how this cell grows, grows, and making a big individual fish. Right? There's anecdotal things that how those cells can be differentiated and can be combined. But if you see this movie, it's very much in detail, and you can see how this complexity is evolving from it, right? You don't have to make a simple toy model to describe this. That's here you go. You can see everything. And also there's Devroy was describing his own son growing up, and he put sensors and auditory sensors, visual sensors, and he could record all this. You should do it with your baby, right?
That's right. Yeah, we always want as scientists to do so many experiments on our own environment.
So usually that there's a very much anecdotal thing that my baby is like doing like this, and then developmental processes must be do like this. But if you use like a machine, recording systems, then this is non-biased. So human cognitive bias is bypassed, which I think is good, right?
Yeah, instead of going through your own, I guess, story, right? Your narrative. Just look at the data, right? And we have this luxury of looking at the evolution, the emergence of lifelike patterns within ALife systems that become more and more complex right now. Or like you did it, looking at real social systems or on social media, for example, and capture them. And I guess looking at the complexity as is, right? Like instead of just checking your specific hypothesis, which is great, but just looking at all the data and then allowing yourself to be somehow surprised by this pattern. Okay, so this somehow jumps at you.
That's right.
You looking for something. That's a very, very different approach to science, I think. And maybe it's difficult to apply, but do you need then to be more than human, to be able to be a scientist. Maybe you need to extend yourself, because you can't maybe capture everything.
Actually at 2000, I think this was also in 2009 that Ross King published the paper. The title was Automation of Science. And then after that, he also coined the term Adam and Eve. So Adam does the real chemical experiment, right? So like a robot arms is moving test tubes, and incubators automatically bring test tubes from it, and then do something and then bring it back. And then Eve can update hypothesis by looking at those results, what Adam did, right? So Adam and Eve collaborating together and do some good experiment, right? And this as a whole is a scientist, right? Now what scientists do can be replaced by Adam and Eve. So that's what happens 2009. Of course, it's deep learning came out right at the same time, so that it's was hidden by this big movement. However, this automation of science is also using these deep learning techniques that Adam and Eve can be more accelerate the approach of this Adam and Eve can be accelerated, so that we don't have to maybe we can bypassing cognitive biases of humankind. Then this Adam and Eve can provide you some interesting scientific insights. That's I think it's one of the future. Well, I think it's near future.
Near future, right? Like we're already somehow using a lot of deep learning or other either automated processes or algorithms to do science already. And in some way, this is an extension of our arms, right? To do experiments, but also to measure different things. So that's definitely super exciting to be using that. But somehow, maybe we don't use them as tools. Maybe we're coupling with them like colleagues, and maybe very soon this is.
But the point is whether the Adam and Eve can think us as a good scientist, good collaborator, right? Maybe they don't. We
are terrible collaborator. Maybe we are terrible scientists.
There's so much bias. We don't understand the complex mathematics, and why Adam and Eve have to work with humankind. Maybe that's what they are going to think about. But well, maybe there's some other thing, because Adam and Eve is a part of the society that we are living in, right? So in order to organize the society and to manage the society to run well, maybe they have to care us also.
Yeah, for sure. This is something that maybe we are building, and maybe that's a responsibility for our field in artificial life, to build a caretaker for humanity, right? Maybe building some form of intelligence or life that can interact with us to make us better.
But Olaf, so idea is Adam plus Eve is artificial life, because this is artificial life because it's autonomous. They can do they can do an experiment. They can update the hypothesis. They can make a story, right? And they talking together, right? And then do some nice science work. So this is artificial life. So the first artificial life can be a scientist. That's my hypothesis.
That's right. That's very nice. And also kind of jumping a few steps. Right? We normally go about and create a world where a simple cell happens the first membrane, or very very simple mechanisms, maybe some feedback loops. But here you jump directly to the other extreme.
Either original life or
So it's sort of bottom up and top down at the same time, which I really like. Maybe jumping to what I forced you to bring here.
Right.
Do you want to present a few books that inspired you, or it could be also other people and maybe libraries that.
So this is End of Physics, written by Otto Ressler, one of my heroes. Also, it's motivated why I come to this field. And then this is Bob Rosen's Life Itself. And I think it's briefly speaking, why this book is important is something which is missing from the current artificial life studies. These authors want to say that there is a big hole in our the real world, right? And this whole is uncomputable, so that even if you make some nice formalism or nice computer simulations or whatever, it's always there's something that you cannot simulate, you cannot touch. That's what also the life is about, right? So it's more like a uncomputable or unsimulatable, or it's something we cannot understand, right? Which is also unaccessible right now. So this is very much a paradoxical thing, but that's what our life is. That's what life is about. That's why it's not a simple material, but it's well, if we really want to understand what is mind, what is life, what is evolution, that we have to think about the frame, not only the frame, but the frame which is out. There is always out of frame, right? And then once you think about this frame, but then because you can think about this frame means that there is a outside of this frame, right? You cannot think about only this glass, because there's other spaces around it. That's why you can recommend this is a cup. Life is the same thing. What the things that we are doing is the same thing. That if you think about something, that you have to think about the around the something that you're looking at.
It's very difficult because whatever you look at, well, as human or as a cognitive system, you have to have your attention on some kind of limited systems. Even in mathematics, you start from a limited frame or a set of axioms. It's hard to think of anything outside by definition, right? By design. So how did these ideas somehow change you and your research? Well, what did you create from it?
Well, I couldn't really do directly to this kind of topics, because it's interesting. But once you want to do some concrete work, that it's difficult to apply, deploy those ideas into your models. But for example, like if you like one of the models that I did was coevolution of tapes and machines. So usually the people think that DNA has a universal code already, right? So the meaning is fixed. But what I did was maybe the information can be different, so the code itself can be evolved. So it's depending on who reads the tape. So if the French people read the Japanese sentences, can take a different meaning from it, right? Or if Japanese people read the French sentences, cannot get different meaning or different. So that should also happen to evolutionary systems. That's what I did as one of my work, right? So this meaning is not fixed, but it's always floating around the like genotypes, right? So that's something that I got from this. And also the function itself should be defined by itself, is also the part of the machines and tapes things, right? So how to read the tape is determined by other machines and tapes things, right? So there's nothing like here's a fixed frame, here's a fixed function that you have. So the system is following these functions on the frames, right? But sometimes system want to get out of this frame and want to change its functions, or that's what I I really wanted to pseudo simulate all this kind of stuff, aspects. So that's what I also did.
This is so important. I think to have different, I guess, more than one observer, or more point of views, or conflicting meanings within one set or one system. I guess it's also simulating somehow replicating something like society of scientists, or any society that has conflicting ideas. And I guess there is no real unambiguous way to communicate, apart maybe from mathematics, but even then you would tackle it differently if you have a different observer. Even on the same set of axioms, they could have a different color,
right?
And this is something that is not very easy to tackle, also kind of ignored. So maybe that could be one of the future directions for artificial life. And so would that be important? And
I think it's well, I don't know how to do it, right? But what I think is important is not just try to explain something that you see, but we always have to think that there might be some other way to look at the same phenomenon that you're looking at now. Right?
Right.
So that might require different kinds of mathematics, different kind of approaches. I don't know whether this is a relevant example or not, but GPT-3, the recent big NLP machine, you know about this? They have, I don't know, 10,000, 2,000 billion parameters.
Yeah. Yeah, at least a few billion.
19 billion, 20 billion, 195 billion parameters.
Yeah.
With 10,000 billion corpuses that can deal with. Yeah. And then, so I recently I got the API from Google, OpenAI, and then I tested and I played around with it. It was very interesting. They was very intelligent, very emotional, and then I pretty much sure this has already passed the Turing test, right?
Wow, the Turing test, the way
of course, there are a bunch.
It's not so interesting, but maybe there are future Turing tests that designed that it can.
But do you remember, like 30 years ago, there was an ELMA network that in order to let network learn, that we have to gradually increasing the corpus size, and then ELMA network can learn the grammatical structures and all that, right?
Yeah, it was just a few years ago, right? Like I was also So these ELMA networks were just like gradually learning like just a simple sequence.
But the point is, the ELMA network can learn language as if we learn acquire language, right? But the GPT-3 is a totally different approaches. They can immediately go to this level, which at the level of like 15 years old, from the beginning, right? But the ELMA network has to go go through the same processes that we take, right?
That's right.
So in order to get to the same state, we have two different approaches. Artificial life, maybe in order to understand evolution, or in order to understand how the complexity of evolution or living systems, maybe there's different approaches using those the current AI techniques. So that's something also I'm expecting.
Yeah, definitely. As the techniques are evolving, there will be completely different approaches, and I'm guessing the next approach by artificial life is hard to predict right now. I think we might see a bit like GPT-3. Or those language models also for transformers in general, and we can see the tools coming up before, and it's hard to predict what they will come up with exactly, but we see the promising like big peaks that will be actionable for new science. And we can see that some of the open-ended kind of science develop similar techniques that are not exploited yet. And it's a matter of having that combined with the tools, I guess, computing power or whichever substrate we'll use. Maybe we'll use something different in the future. Maybe quantum. Maybe something else.
Well, I usually, the Jordan Polak, one of my friend, also a big artificial life researcher, that he says there should be a deep evolution, right? Once you iterate the steps, not only like billion steps, but billions of steps, then maybe there's something new kind of structure emerges. So deep evolution is I think it's one of the paraphrasing open-ended evolution, right? So we should, maybe there's another strategy to tackle those long-term evolutionary phenomena.
That's right. Yeah, which would be a fascinating thing to follow and also participate. What is your next step yourself? I hope you're not receiving this award. You're not retiring, right? You're continuing. So your next
that's exactly what I was afraid of. Receiving this kind of award, means that I have to retire.
No, you don't. Officially, I'm telling you, you're forbidden to retire.
So one of my ideas is that, as I said, Adam and Eve. The first artificial life maybe is not the original life stage, but maybe you can think of like another extreme end. maybe this neuroscientist, automated science, scientists can be the first artificial life thing that we can.
So I guess as we go, we'll create tools that are more and more autonomous and that we interact more richly with.
Yeah.
So I have this personal, I guess, direction of research that I'm interested in, which is creating tools that are not really rich, only rich like GPT, which are obviously very powerful and exciting. But if you interact with a machine, right? Right now you have some input and output. The interface is kind of basic. But even if the interface is basic, maybe we can find ways that we can interact deeply with it, that we can perceive through it. So I'm thinking of the way we interact with Google Maps is very basic, right? It's you don't perceive the map, and maybe we will also lose this ability to orient ourselves and find places with maps.
That's right.
But instead, maybe something like inactive torches or something like the blind man, the blind person's cane, maybe something like that, right? Like through which you will sense reality. So if we could make an ALife unit that could interact with us and through which we perceive reality, and maybe they perceive also reality through us, that might be the most exciting thing that we can create.
Extended embodiment, right?
Extended our exactly. We extend our embodiment through this creation, and definitely those devices right now, the computers, they extend a little bit our embodiment, but I don't sense through it completely. It's very narrow in terms of not only the channel in terms of information, but the richness of the signal and how I perceive the signal is very limited. So maybe this is a next direction that is more cognitive, I guess, for artificial life.
Yeah, I think. Do you call it cognitive? Because I always think that people have been discussing about consciousness. The consciousness is about the motivations and actions and what you want to do. But I'm more interested in like unconsciousness level. So unconsciousness is very important. How you can organize the conscious level. Right? This big sea of memories. I don't know, but this is something that we are sort of missing if we want to interpret what's going on in this with this agent, with this robot, right? If the robot can have an unconsciousness, that's, I think, it's more important, because it's consciousness is something that we can interpret the what he will going to do, why he does this. But unconscious level is that we cannot tell, right? But that's how it determines the future sensory actions.
That's right. It still does it, and I guess there is part of it. Whether it's relevant to consciousness or not, like I'm not sure. I'm not sure I'm interested. I'm not sure what it means yet. So I spent a lot of time, I guess, trying to understand this, as you know, and you too, right? But part of it, connected to this unconscious, and I guess it's linked to, you would say, in a bad way, you could phrase it as manipulation or hacking into another system. But in a good way, you could say that it's a way of feedback and control, and gaining more of that control over the system or yourself. And things like hypnosis or implementing those and recreating those in artificial systems is the exciting direction.
Yes, I think so. Yeah, I'm also very much interested in that kind of aspect. So why we can hack our brain, which you call hypnosis, right? Is something I think it's opened up the new way to understand how the brain works, how the mind works. It's not just a isolated network from the external world. It's more like a leaky.
That's right.
Integrated with the environment, and that's something we have to update the notion of neural network. Maybe we have something different. It's always I'm hoping for bringing up some new kind of messy network.
That's right.
Which is loosely connecting with the environment, right?
Yeah, Yeah, I do feel like those systems are too neat, and I need some kind of messiness, like leakiness to them to be more interesting.
Right. Yeah.
But also, yeah, I guess those there is, I say cognitive. I guess it's in the large sense. But those systems you can couple with as an agent, right? Yes. And forming somehow instantaneously entities of higher order, right? So something like that you can see in swarming, for example, right? Like where entities create a sort of group we intentionality, and through which you can understand how you don't have all the memory. The other doesn't hold also the other memory, and it's not only about memory. It's also the rest of the computation and the attention and so on. All of those don't exist in one agent. They are somehow existing only in the shared entity.
That's right.
And those can change dynamically. I think it already exists, right? In society, we can observe that. It's just very hard to frame because the way science works is that you have again this frame, and looking at it out of frame maybe is the exciting.
Yeah, but that's what these people wanted to understand.
That's right.
Yeah. So maybe we should update our modeling brain systems or the mind or the evolution systems also, right? In order to take into account those out of frame frame of reference program, then we have to create new approaches to it. Maybe it's not there yet, but maybe new kind of technologies like GPT-3 will come up, and then we can tackle this problem more easily.
That's definitely super exciting as next steps.
I think that's what artificial life is going to be, right? We are on the right track, I hope.
I hope so too. So maybe one last question would be how does artificial life and all this science impact our life and maybe your own life? What is your experience of how it changed you as a human? You're not only a scientist, you're also a man behind.
That's right.
So how did that change you, or how is it changing you now?
I think this is also your case, but our job and our personal life is not so much separated from each other, right?
I don't know for the best or not. It's hard to somehow distinguish both right now. So Are you the A-lifer?
I think doing artificial life, we can practically use the concept of diversity. So I call principle of diversity is people say that, and people can hear when somebody said this, right? But artificial life, if you seriously studying artificial life, diversity is the principle, right? It's not just selecting one good elite, but how to retain diversity, and then how the diversity is essential for understanding living system is what artificial life is also a big message that we can take, right? So the principle of diversity should be what we have to follow in the real life, and then of course there's the people gradually notice that we have to think about different types of style of life or different ways of understanding how we living by. I mean, like LGBT Q is something, it becomes a big trend, but that's what in the end the principle of diversity is behind this trend, of course, and that's how this artificial life is not just a branch of science, but also is strongly connected to our real life, and then this principle of diversity going to be the main principle of our personal life also, right? That's why I think artificial life is very important. It's connecting our personal life and research life.
It's and it's very unique, I think, and we are really lucky. It's not the only field that connects deeply with philosophy and the nature of our living. but it's a very special community, and I'm there also next thanks to you, right? Like you introduced me to a lot of this, and I'm really thankful. So I'm really happy to
I'm really happy. As we've been discussing, like so many different types of people are coming from all over the world.
That's right. Yeah.
So sometimes this is tough, but that's what diversity means to me, right?
That's what
to
it
us.
is. Yeah.
So it's not just clean something, right?
Yeah.
It's not the safe and clean and ideal or something, but the diversity itself is very messy, and that becomes the philosophy of artificial life, which I think is very nice.
Yeah, it's very interesting that when you have a lab like yours, and also at Cross Labs, we really welcome people from very different backgrounds, and we're really excited to have. Okay, you come with this background that we don't really know. We don't have the tools maybe to communicate yet, but we are tackling the same kind of questions, right? About the nature of the living, and all connected. And I think this type of openness to diversity and openness to
openness to diversity. Yes.
Yeah, that's right. And create this new I guess language together. That's the exciting part. Yeah. Those are very very important values, I guess, and. Yeah, I'm really excited to see what ALife is doing next.
Yeah, I do. Yeah, I'm very much expecting for new people to come to the to ALife and then can develop into a very nice and interesting and exciting directions. Yes.
Yeah. All right. Thank you so much
for
coming to.
Thank you very much, Olaf, for this interview. Thank you.
Yeah. Thank you.